Hello. Today we have an RX570 4 gig from Sapphire. This came to me as broken, and I want to start by checking some resistances and voltages. So let's start disassembling the card. This is going to be my first video. I'm hoping that we can diagnose and repair this card. Let's start by disassembling the backplate. No, the backplate is out. So as the shroud. Let's talk about the story of this card while disassembling. So I bought this card as broken. The previous owner said that he shut his PC down, he went to sleep, and the next morning when he tried to power on his computer, he had no picture. He had picture with integrated graphics, but no picture with the graphics card. The fans were spinning, but no picture. Cooler. Come on. Why don't you come out easily? It's stuck. Oh, here we go. Oh, you forgot one screw. That's my bad. Okay, come on. Oh, here we go. The paste looks not that old. Let's use the resistance mode. I'm going to probe ground from the shroud. This should be VCO 0.8, 0.7. It's like 0.5, 0.4 ohms. This is normal. What about the memory? 30 ohms. What is this? This is Hynix memory. 30 looks okay. What about EDDC? 18. This looks normal. This is packs 17. It also looks normal. Do we have a short on 12 volts? Let's check here. This is diode mode. We have no shorts. The fuses are all right. Okay. There is no short that I could find, so here we should have 5 volts. Let's also check it. Yeah, it looks like we don't have a short, so let's plug the card on a riser and measure some voltages. Cable is a little bit short. Oh. Okay, I'm gonna measure it that way then. This looks okay. Oh, power supply on. I'm going to also plug the HDMI cable. Probably we won't have a picture, but maybe we have some problems with the memory. And we get a corrupt image or something like that. So let's plug the HDMI. The power supply is on. Is it on? Yeah, it's on. Okay, the computer is on. We have a beep. But no picture, no signal on the monitor. So let's start by checking the VCore. Do we have VCore? No, we don't. Do we have memory? Let's use the coil on the back. Do we have memory? No, we don't. Do we have 12? Oh, I forgot to plug in the 12 PCIe connector. Yeah, this is my first video. I'm a little bit nervous. So let's start again. This time we should have some voltages, hopefully. Okay, let's turn on the motherboard. It's on. Let's check. Do we have VCore? No, we don't. Do we have 12 this time? Yes, we do. From the slot. On this slot, we have 0.7. This is not normal. Is my riser broken or something? I'm an idiot. Yeah, that's what's going on. I'm an idiot. Once again, do we have 12 here now? Yes, we do. Do we have Vico? No Vico. Let's check the memory. Do we have memory? No, we don't. We don't have packs. What about VDDC? No VDDC. Do we have 5? 2 here. 2 here. 12 here. Oh. 5 volt is low. That's what caused it. We have a low 5 volts. Okay. So turn off the motherboard. The first two voltages are 12 and 3.3 from the slot coming from the motherboard. Then the 5 volt comes on. If there is no 5 volts, nothing else is going to turn on. So we have to fix that. Let's get rid of the riser and all the other cables. First, I want to clean the GPU with some isopropyl alcohol. Hey, that's a lot of thermal paste. Okay, that's all right for now. Okay. What can cause a low 5 volts? So there's an LDO here. This is our LDO. Let me grab my tweezers. So this is our LDO, and there are 4 pins on this LDO. One of them is 12 volts. One of them is the control, like gate on a MOSFET. One of them is output 5 volts, and one of them is VREF. So there are 2 resistors controlling the VREF. And let's try to find these 2 resistors. So I'm going to check the resistors around. Let me get some cotton buds and clean this area. Some isopropyl alcohol. So these two resistors act as a voltage divider, and in the middle of them and from the ground there's a VREF, and if this 478, this one, around 1.3k, 1.6k. So I don't think these resistors are bad. About here, 9.2k. Okay, so these resistors are looking all right. If one of them was short, I would think that the VREF portion of the LDO is broken. So let me show you the diagram. Let's first talk about the power sequence of this graphics card. We have an RX570, RX570, so we are going to use this one. Like I said, we have 12 and 3.3 volts coming from the PCI Express slot, and using these voltages, 5 volt is enabled. The 5 volt is needed to enable any other voltage under 5 volts. As you can see here, the 5 volt enables the 1.8 volt enable signal. This one turns the 1.8 on. Then the 1.8 power good signal turns the PEX on. PEX power good turns the memory on. Memory power good turns the VCO and VDDCI on. When we don't have 5 volts, any other voltage here from 1.8 enable to VDDC, VDDCI, they can't be enabled. They never come on. When we have a problem with the 5 volts, the power sequence hierarchy is like this for this card. Let's talk about LDOs. The 5 volt is derived using an LDO. This is not the exact one, but this is an example of an LDO. The LDO here is an APL1117 chip. We have an input for a graphics card. This is going to be 12 volts. And out, since this is for 5 volt rail, this out is going to be 5 volts. And there are two resistors to adjust voltage, as we can see here. R1 and R2. Here R2 is a potentiometer because this one is for an adjustable regulator circuit. But on a graphics card, we don't need an adjustable one. We need 5 volts. So there are two resistors to tell the low dropout regulator that we want 5 volts. This one uses a VREF, reference voltage VREF, of 1.25 volts. Ours might be different, I don't know. I didn't check. But for this LDO, it's 1.25 times R1 plus R2 over R1. So for example, if we needed 5 volts, 1.25 times 4 is 5. So we would need, for example, 100 ohm here, or yeah, let's say 100 ohm here and 300 ohms here. So this would become 400 over 100, 1.25 times 4 is equal to 5 volts. This is just an example. I don't know the exact values on this graphics card, but they were not short, or they weren't a much higher value from the other. Like, this was like 1.3 and 400 ohms, I think. If you look at that, it's actually like 1 to 3 ratio. Maybe this one also has a 1.25 VRAF, I don't know, but you can see I checked the VRAF portion, this portion of the circuit first. I didn't see anything strange, so I decided to replace it. What I'm gonna do is I'm going to change the regulator and see what happens, because this is the easiest thing to do when we have a problem like that. So let me grab a donor board. Okay, this one looks like a good donor board. Actually, the boards are very similar. This is an RX580. This should be an RX480 mining model. I'm going to use it as a donor. So let's apply some flux on the component. That you're going to get from this donor board. Let's first apply some leaded solder, so it comes off easily. And then I'm going to use hot air to get it off the board. It's heating up. Yeah, it's off. Let's put this aside and get our board back. Let's apply some flux and Some leaded solder afterwards. Hot air back. Let's heat the area. Okay. Our new part is on. Let's apply some more flux. And do the final touch with the soldering iron. Put some butts, isopropyl alcohol. Let's clean the area while the board is still hot. We don't want flux residues afterwards. Let's let the board cool off a little. The alcohol also helps with that. Okay, so we can test the voltages again after the board cools down. Until then, let me check for any shorts. It's in beep mode. The meter beeps if there's a short. No short. No short. It looks good. So let's check the voltages after the board cools down. Okay, the board is warm now. So let's turn our power supply on and check some voltages. Do we have VCO? Yes, we do. Oh, it's getting out. Let me grab a cooler. Yeah, we have VCO, so we should have all the voltages. That's why I'm going to use a cooler. Yeah, we have one here. But this is temporary. Let's apply some thermal paste. Just a little. tiny amount. Should be all right. Enough just to get a picture. Computer is on. Oh, we have picture. Look. Oh, that's incredible. Okay. So let's do a quick T-server test. I'm going to be back. The card is reassembled, as you can see. I'm going to run a T-server memory test on the card using this thumb drive. This thumb drive has T-server. Let me plug it in. Yeah, it's in. The power supply. The motherboard, it's on. So let's wait for a picture. We have picture. T-server, yes. Yeah, the test is running now. Let's wait for it to finish. I have seen no problems thus far. The test is done. Let's see. Yeah, we have no errors. That's good. Let's shut the computer down. Yeah. Now I can say with 99% probability that this card is fine. It's fixed. I'm going to test it on also on Windows, but I don't expect any problems from it. Yeah. I'm going to continue the video if I see any problems, but I don't think I'm going to have any problems with this card. So thank you for watching. If you have any suggestions, please let me down in the comments. Until the next video, goodbye.